Hello everyone, I'm Thinking Tree, and today I opened this live stream to do wrap up study for today. Today, actually, I'm not planning to do as long as before as usual because today I took a huge test in our academy and they quite burned me out. And also, today the plan for today is to do my school homework, maybe a little bit of my academy homework, and then actually I have science test tomorrow, so I think I need to review and prepare for that. And I heard that the best way to review is to teach others. So even though I never explained science before, maybe I think it'll be a good opportunity for me to try it today. So yeah, let's get started.
응? 싫어. 이거는?
Oh, why is it so laggy today? Sorry. Uh, I think. Oh, I now I will start reviewing the science. I'm sorry about the video quality. It's just so laggy today. So I have chapter 13 test tomorrow, and overall, if I explain what it is about, it's about forces in fluids, and it it contains also 13 is about forces in fluids. Why the English? Forces in fluids. I'll try to write it as pretty as possible. And oh my goodness, this is so laggy. So, chapter 13 is about forces in fluids, and it contains uh, three sub, uh, three, three sections, which is fluid pressure. It contains fluid pressure, and it contains forces and pressure in fluids. So pressure in, and lastly, it contains buoyancy. I will explain what buoyancy is. Uh, so first, I will talk about this section, fluid fluid pressure, and so yeah, fluid pressure. Uh, Fluid pressure. So before I talk about what fluid pressure is, I'll first talk about what fluid itself is. And fluid, according to the definition from the book, fluid is a substance that assumes the shape of the container. And so fluid is anything that flows. So, for example, the example of fluids can be water because it can flow, and air, just the atmosphere, and also any liquids like honey. They are also all fluids. Now, then, what is pressure? Pressure is the result of force distributed over an area. So it can be, so what pressure means, how is force distributed an area. So pressure is describing how force is distributed over an area. So force is a push or pull of an object that acts on an object. So how does that act on any certain type of object? That is what the pressure is talking about. So we can write it actually in a formula. So pressure P is equal to force F over area. So this is the general formula for pressure. And we can know that if the area decrease, then, and assuming the force stays the same, If area decrease, then automatically pressure increase, while if area increase, then automatically the pressure will decrease. However, if you assume the area stays the same, if force increase, pressure will increase, and if force decrease, pressure decrease. So what I'm trying to say is that pressure and fluid force, they are directly proportional, while pressure and area, they are inversely proportional. And I will give any some famous example for this. So I have you guys saw this where they say they will place like I think I read this in a comic book. So if a person stands on one nail, they will hurt a lot. It will be very dangerous. However, if a person stands on thousand nails like this, then the area, even though nail itself is very sharp, the area of contact is way larger than here. That's why the pressure is lower here. The pressure that of for the how should we say, the bottom part of the foot is way less. Therefore, you don't get hurt actually. I think that's what the pressure is talking about. And oh, by the way, the SI unit for pressure is Pascal, is short for PA, and we usually write it as kilopascal because they are usually very big. So kilopascal is just 1000 pascal, and I'll give you one example for it. So let's say a force of maybe, so here's a box, and let's say there's a ground, and the area here, area of the contact is 1.5 meter squared, 1.5 meters squared, and the weight is um 2700 newtons. So we can write known. We so we can write that known. The force that is acting, because weight is a force, is 200 newton, and the area is 1.5 meters squared, and the unknown is so we're supposed to find how much pressure is acting on here, and we know that P is equal to F over A, so therefore it's 2700 newton over 1.5 meters squared, and by using the formula we can know that 1 Pascal is equal to force Newton over SI unit of area is meter squared. So we can convert it like this. So therefore, this is equal to 1800 Pascal. So 1800 Pascal or 1.8 kilopascal of pressure is acting right here. That's the example, and I think I'll just have to keep going. And that was generally what the uh, pressure and fluid is. Next, I will talk about uh, how pressure, how pressure, how pressure is exerted in any kind of fluid. So, as I mentioned, fluid is anything that can flow. So it assumes the shape of container, like liquids or gas. And oh, that's clean. And in water pressure, mm, so for it says for fluid pressure, there are two things that affects the pressure in fluid, and one thing is the depth, and the second thing is the type of the fluid. So first I will talk about the depth. So when you free dive or when you go deeper in a pool or any kind of liquid, you need to equalize the pressure inside your ear and outside your ear. So in Korean, or you just call it as equalization. And the reason why you have more pressure on deeper when you're deeper when because is it going to be mentioned? I don't think so. It's because so imagine there is any container that looks like this, and there will be water molecules here, here, here. There are, and I will explain this further later. But the the pressure that is occurred by the fluids is all constant here or here or here or here. However, the pressure in here, when it is deeper, the bottom of the container, it will be greater because you have more water from the top that is pushing you down. So there are more water molecules that are pressing you from the top that causes more pressure. More water molecules or any liquid or fluid, and it causes um more pressure. Causes, yeah. And second is the type of the fluid, and I don't think the book really deeply mention about the type of the fluids. However, I think uh if it's more dense, maybe you will have more pressure because there are more molecules that are causing the pressure. I'm not sure about this one, and I think it's the density. Now I want to talk about air pressure and atmosphere, and I don't really get why this is happening, but when you go higher in altitude, then I heard that it's harder for you to cook because even though same amount of heat is produced, you have less pressure that actually cooks the noodle, and I think that's because uh, the heat causes all the molecules to heat and cook something, I think. And as the altitude increase, there are less pressure and less molecules. So you don't have lots of those kind of molecules that allows you to cook. Therefore, I think it's harder for you to cook there. I'm not entirely sure about this, but this is how I understood. If I made a mistake in here, please let me know. And there's one interesting fact about uh about air pressure. So let's just say this is a normal human. Here, here, there will be 101 kilopascal of pressure from the atmosphere, and also this is over 1,000 Newton. Isn't it quite amazing? Now I want to ask one question. Then, if that much force and pressure is applying on you right now, why aren't you crashing? And sorry, and the answer is because your body also contains air molecules, and it also causes the pressure from inside to outside. So, I am really bad at drawing, but let's say this is a human. So if pressure is occurring like this here, then there are pressures from inside you that cancels out this force, those forces, and that's why you're not being crushed. However, when you go to space without space suit, then you will have all those pressure from inside you, but not outside, that causes you to explode, which is not an ideal thing to experience, I believe. And I actually kind of want to explain how you are able to breathe air, how you're able to inhale and exhale. So your body has a muscle named diaphragm. Oh, how do I spell it? How do I spell it? I believe it was D diaphragm. Dia. I'm not sure. However, these muscles, when you try to inhale, then let's say this is your lung, and your muscle will move like this way. Then that causes less space here. Wait. Oh, sorry. So this, when you try to inhale, then the muscle diaphragm here uh, expands like this. Now, then your lung will have more space. Your lung will have more space here. That means you have less pressure. Then, to equalize the pressure, the air molecules from outside will go into your lung. That's why the air comes in. However, when you want to exhale, then your diaphragm will move like this way, causing less volume here, and it causes more pressure. So the air molecules will likely to go out, and that causes you to exhale. It was quite interesting for me too on this one. Uh, Next thing that I want to talk about is I finished section one, and I just realized that I learned of something while explaining, which is good for me, and I believe for you too, hopefully. I want to talk about forces and pressures in fluids. So according to Pascal and Pascal's principle, uh, the pressure is exerted equally throughout everywhere. And if a pressure from outside is exerted like this, then this pressure will be transmitted to here. So all the pressures will actually change. Now, by knowing this, we can actually make thing called hydraulic system. So have you ever wondered how uh, if let's say there's a dump truck that looks like this and it is able to lift very heavy thing like this? It's because they are using thing called hydraulic system, and what hydraulic system is using is it is using Pascal's principle. So basically, it kind of looks like this, and it's called there is slave piston and master piston. So as I just told you, uh, the the pressure, even if there are external pressure or any forces that is applied to here, it will be equally transmitted. So let me just say this is a master piston, and this is a slave piston, and apparently this one will have much more surface area compared to here. So as I mentioned before, uh, pressure is equal to force divided by an area. So I will just say the area in here is A sub 1, and force applied is F sub 1. And area applied here as A sub 2, and force applied here as F sub 2. And I just said F1 is smaller than A2. And by knowing Pascal's principle, if I exert a pressure here and there's like any kind of fluid here, then all this pressure will not change. It will stay the same and move to here. So when I say the pressure here is P1 and here P2, then I can know that P1 is equal to P2. Now P1 is equal to F1 over A1, and it is equal to F2 over A2. Now, because I know that A sub 2 is bigger than A sub 1, then F sub 2 must be bigger than F sub 1 to make this possible. So basically, I will just assume that A sub 2 is equal to maybe K times A sub 1, where K is positive integer and K is bigger than 0. Then I can write this as A sub 1 times K over F sub 2. Now, since they are the same, I can say that I can cancel this 2 out, and I can multiply K to here, so F sub 2 is equal to F sub 1 times K. So basically, if you increase the area here by, like, maybe I'll say twice here, then the force exerted, the input force, the output force here will be twice as big as the input force. So this is how the dump truck is able to lift very heavy things. Also, for your car brakes, your foot actually exerts only small amount of force. However, by using hydraulic system, it can exert much greater output force by having much bigger surface area here. And that is the real life example of using Pascal's principle. And next thing that I want to talk about is called Bernoulli's principle. So have you ever wondered about how airplanes, those heavy things, are able to fly? Maybe how birds and how things are made and well, is able to fly, and it's because uh, it is an example of Bernoulli's principle. So what Bernoulli's principle is saying is that as the speed of a fluid increases, the pressure within the fluid decreases. So what that means is that let me just say this as a airplane wing or something. Then this is just a natural law of, I think, nature. I am not quite sure about this one. We didn't learn it. And I think we just need to assume some things. We just need to accept some facts. So wh- when he- so let me just say this is in the atmosphere. So if there's air here, then you want to go here like this. However, because it used to go like this, but there's this kind of shape here, it needs to go around like this. So the distance from here to here is less than the distance from here to here. Then in order to travel um, much greater distance in a certain given amount of time, then the speed of air in here must be greater than the speed of fluid moving in here. So by knowing Bernoulli's principle, since the speed in here is less than greater, then the pressure in here is less. And this is also the thing that you just need to accept. And if there are any difference in pressures, they will like to equalize them. So since we know that the pressure in here, let me just say the pressure in here is P1 and pressure in here is P2. Because we know that P1 is greater than P1, P2, P sub 2. This all the air molecules in here will like to go up. So they need to go up. However, this thing is blocking the way, and because it is blocking the way, and this all the air molecules will like to move up, it is causing things like airplane and birds to be able to fly. And the force, the upward force that I just explained is known as lift. And I think this is quite interesting because when you also look at the spray bottle that you use, thank you, that you use, uh, if there is what if you're using a spray and that looks like this, and you have the liquids that or fluids that you want in here, and let me just say you have very fast moving water that pass through here, then since the speed in here is greater than uh the is very moving very fast, then the pressure in here is greater than pressure in inside is greater than the pressure in outside because the fluid is moving very quickly here. That's because of the difference in pressure. This higher pressure will like to move to a place where it has lower pressure, causing all the fluids in here to move up, and that causes the water and the fluid to mix up in here, and that allows your spray bottle to be released. And I think this was quite interesting for me too. And 13.3, this is my our last section, and it's about buoyancy. And buoyancy is, I think, is the ability of a fluid to exert an upward force to an object that is placed in it. So when I just quickly draw it, let me just say there's water here and some kind of, maybe I don't know, maybe an object stays in here. Then the buoyancy, the force from a fluid, allows the object to be lifted. And this actually, the buoyant force depends on two things: is the density of the fluid and an object. Um, so before I go on to that, I kind of want to mention about Archimedes principle. And what Archimedes principle is saying that is that the amount of fluid displaced, the weight of fluid displaced is equal to the buoyant force acting on an object. So I think many of you know about uh, Archimedes are doing saying Eureka. So I think there are lots of cartoons describing it. So there was a silver crown, I would say, and a golden crown. And as this was placed in here, um, the water actually overflowed it. So water actually overflowed it like this, and there was a crown here. And the amount, when we gather all the amount of water that was uh, displaced, then all the weight of all this water is equal to the buoyancy, the buoyant force that is acting on this object. So by knowing this principle, we can explain how ships are able to float on top on the water, and I think like oil tanks, which are vessels that carry tons of oils. It has very high mass. Then how is it able to? How is it able to? How is it floating on the surface of the ocean? And that is because of the density. And I will just quickly explain what density is. So when I say density, density is mass divided by volume. So it's how much mass. It's a ratio between the mass and the volume. I forgot the symbol for density. Was it? I'll just say D. I'm not quite sure about density. So its density is equal to mass divided by its volume. So I will say if there are two square cubes, like squares like this, and no, I will just say cube. And if they all have same, if those two have same volume, and if this weight, maybe I will say, if the mass of this first one is 2 kilogram, and the volume is maybe, I don't know, 1 meter cube, 1 cubic meter. And for the second one, the volume is the same, 1 cubic meter. But if it is 1 kilogram, I can know that this one is much more dense than than the second one, because it has more mass in a given volume. So actually, the reason why things are able to float in water is because their density, if the object's density is less than or equal to, the object's density is equal to the density of the fluid, because when they're less, they will be like levitating, flying, which doesn't make sense. So there are actually three scenarios. I'll say the first scenario is suspended. The second scenario is floating, and the last scenario is sinking. So let's just say there's fluid here, and what suspended mean is it is not floating or it is not sinking. So it is just right here in the middle. And in Korean or in freediving, you just call it as 중성부력, which is really hard thing to find as a beginner. And floating is, like everyone know, it's just floating here. I would just say ground is right here. And sinking is just sinking here. And the reason why it occurs is that let me assume that, oh no, just I will say the density of water here is maybe D1, and here is D2, D3, D4. Now, when D sub 1 is equal to D sub 2, this happens. It doesn't float or it doesn't sink. And the reason is because if the density is the same, and in a given amount, if the density is the same, then the amount of water replaced will be same as the mass of this object, and that's why the weight that is pressing here is equal. The weight that is that is pulling it down is equal to the buoyant force that is pulling it up. So it doesn't. So those two cancels out. So nothing happens to this one. Now this one also happens when D sub 1 is equal to D sub 3. This is the case when this and this, the weight of this object is same as the buoyant force, or sometimes is the buoyant force is sometimes greater, so it just miraculously like stays like this. And this is the second case where it floats. And the third case is when D sub 1 is less than D sub 4. So because it has a higher, because it weighs more, it is the force that it pulls down, which is the weight, is greater than the buoyant force. The buoyant force doesn't have enough force to pull it up to the surface again. And these were the three scenarios. Now, I quite found this interesting when the book explained about submarine, how submarines are able to level itself in water, and how is it coming back to the surface again is by uh, putting water in it. So when I just quickly sketch, so submarine contains oxygens or any fluids that can push the water out that went in. So let me just say this is the submarine, and they will actually intentionally pour water in here so that the density increase and becomes higher than the sea water, and it causes the submarine to sink. However, by releasing air, because it's a law of matter where two different objects or substances cannot occupy the same space, so they actually push the water out, and that lowers the density until the point that they are equal to the density of the sea water, and it allows a submarine to float. Now, do you know about Dead Sea? I believe it's in Egypt, where the amount of salt in there is so high that the seawater actually it is so dense than the normal human body. So when anyone just goes in there, they just will float because the density of the Dead Sea is so high. And the last thing that I want to talk about today is about the oil tank. Yeah. So the usually a large vessel have a shape of hole that looks like this, and this is the secret of how those very heavy vessels or ships float. So as I mentioned before, according to Archimedes' principle, uh, according to Archimedes' principle, the buoyant force is equal to the weight of the fluid displaced by an object, by this object, and by increasing the volume, it also has very many space in here, and it increased the volume so much that it displaces so much water, and then the same amount of buoyant force is acting on it too. So ship will never float if they have the shape like this, where it has so it is so dense and it has so less mass where it displaces the fluid. However, when it increases its volume to lower its density like this and have so many empty space here, it will allow the density for the ship to decrease and allows it to float. Um, I today I talked about forces and fluids, which was about fluid pressure, forces and pressure in fluids, and buoyancy. And it was a short review for me to prepare test, a science test for tomorrow. And I think since I have midterm next week, I might do the similar thing for the whole chapter because like everyone says, the best way of learning is by explaining it. So yes, for the rest of my time, I believe I will just write and read Bible. Wait, I know I need to solve some math problems. Uh, I think. Oh, it's over 12 today. I think today I will just read Bible and go to sleep. I just read Ruth chapter 3, and I think it was about how Ruth was faithful and very trusted, and like in previous chapters, as previous chapters mentioned, Ruth was a very faithful woman, and it is showing how God blessed Ruth for her faithfulness uh, through Boaz. I just wrote a Proverbs chapter 15, verse 10, and it is saying that stern discipline awaits anyone who lives a pet. The one who hates correction will die. And I think this verse was uh, quite quite scary verse where it talks about how, because in other places in Proverbs is saying follow your parents and and love discipline, and also be willing to learn from it. However, in this time it showed the consequence of not trying to listen to disciplines, which is um might be death or any terrible things. So today I learned that I should be more careful to all the correction and be willing to learn from it. Today, because I came back from academy quite late today, I was not able to stay here for so long here. However, tomorrow I don't think I have special classes, so maybe I'm planning to open it around 9:30 to around 12. And thank you so much for being here together. Then good night and see you tomorrow. Thank you. How many hours a day? Uh, I think around six. I sleep a lot, maybe around 6 to 7 hours. Thank you.